Hello friends, thank you for watching this video. I am Mohamad and today we'll be going through infrastructure as code with Terraform and Azure DevOps. So, what are we going to be covering today? First, we're going to be going through a brief history tour. Then we're going to be discussing the divide and conquer concepts. Then we're going to be discussing what is infrastructure as code, what's the benefits, what's the process that we're going to be following, and then we're going to be discussing some of the ingredients that we want, and then we're going to jump into coding and implementation. As always, you will find the source code for that in the description down below. Please like, share and subscribe if you like this video. It will really help the channel. So let's start first with a brief history tour. In today's development environment, we hear a lot the word provisioning, configuration, deployment, pipeline, orchestration, and automation. But what are they? And how do they work? And how do they complete each other? So let us see how deployment used to and still being sometimes done. In the past, before automation, when we want to build our application, the deployment process was something like this. First, we needed to find the server. Once we have found the server, then we needed to decide what type of server it will be. Will it be a Linux server or a Windows server? And based on that, the basic configuration for that server needed to be done. Once those configuration has been done, the next step was to configure the network, to provide a DNS for that server, to provide the dedicated IP address, specify the networking rules. And once those configuration has been done, next we needed to install the dependencies. And all of those dependencies, for example, were like the SDK that were supported. For example, if we're using .NET, we need the .NET SDK installed. If we're using Java, we need the JVM installed or the Java packages installed. We need Node, for example, and all of those need to be installed. And the next step after installing all of those dependencies was to actually configure them, to link them to our web server, and to make sure, for example, to make sure they are available on the startup of the server. And once that was done, the next step for us was to actually configure the security. And basically we needed to set up the firewall, specify the inbound and outbound rules, specify what ports will be open, specify if the access to the actual hardware level. So if we want to enable direct file upload, or we want to, for example, enable access to the hard drive. And once that has been done and all of the security has been configured, the next step for us was to actually install a DB server. And the DB server could have ranged from MS SQL to MySQL to Postgres or any other type of servers, DB servers. And from that point, we needed to configure the application, or basically our web server, to acknowledge that the DB server were there and to make sure that there was no conflicts between them. And the next step after that was actually to install our application and make sure that it's actually enabled within the web server, and to make sure it has a proper connection to the DB server, and all of the security and all of the guidelines that we needed for that application to run successfully was already implemented. As we can see, there's a lot of stuff that has to be done manually, and all of these preparation were required just to make the application run on all of the servers. And all of the steps mentioned will have been done manually. With all of these steps that we have mentioned, we still didn't cover a lot of other points. For example, how are we going to handle scalability? How are we going to handle backups, maintenance, security monitoring, environment management, and even data backups? This work will have needed to be duplicated and repeated for all different environments. So for example, in our case right now, let's say this was the production environment, but we need to duplicate it, for example, for QA, we need to duplicate it for development, we need to duplicate it for different, for example, product environment. So that work needed to be repeated multiple times. And as well, that repeated work could have also led to a lot of human error, and it was prone to a lot of human error, because whenever we're doing something manually and we're doing a lot of configuration, there's a lot of margin for error. So in order to solve all of these problems, we can utilize infrastructure as code, or as a short, we can say IAC, infrastructure as code, and we can utilize them in order for us to automate all of these processes and to actually make it better and make it faster to deploy and actually have our application up and running in no time. So In the brave new world of DevOps, all of the stuff mentioned earlier can be decoded and be automated and powered by the infrastructure as code. So this leads us with infrastructure as code as a way to automate all of the tasks that we needed from start to finish and automatically basically run every single step and make sure that we got the same result every single time that we do. And that will remove all of the manual work and make it way less prone for human error. To accomplish this, we utilize different tools and programming languages. And some of these, for example, are Terraform, Ansible, Puppets, and there's so many more. But for our video today, we're going to be only focusing on Terraform and building from there. So, we're going to be going through right now what is the divide and conquer. So, divide and conquer when it comes to infrastructure as code is going to be separated into three different sections: provisioning, configuration, and deployment. So provisioning the infrastructures mean that we're going to be creating those servers, we're going to be configuring them, basically configuring the networking, configuring the load balancers, configuring the communication between the different services that we're going to be managing. And once those provisioning has been completed, we're going to be jumping into the actual configuration. In that configuration, we're going to be, for example, telling it that we need certain SDKs, certain packages, and from those certain packages and SDKs, we need to actually configure them to work with those servers. So for example, if we're using Windows servers and we're using .NET Core, we need to install some tools so the IIS will be able to know how to utilize .NET Core. And from that point forward, it will automatically know that those servers need to start up when IIS starts. And once we have done the configuration of the infrastructure, the last step is to deploy and configure our application. So once we have done that, the application has been deployed. We can deploy the application. It can, for example, run on IIS, and it will automatically take up the default SDK that has there. And for example, if we need to install a DB server here and actually configure the DB server to work with our application, we can actually do it from here as well. So the divide and conquer process when it comes to infrastructure as code is straightforward. So the first step is we provision them. We define what's the servers that we want, how the configuration will work, what are the requirements for those servers. And once that's done, we install the different tools that we need, the SDK, we need a DB server, we need, for example, certain extra email services that we need, for example, some queuing services, some bus services. All we do is we configure them from the infrastructure configuration. And then after we do all of that, we actually deploy our application. And once we deploy our application, we can configure it and actually utilize all of the steps from before. But I just want to specify a single note here. If with the current utilization of containerization and Docker, step 2 and 3, which is configure infrastructure and deploy infrastructure, could be merged into one, because when we build our Docker container, we actually specify those configuration inside that Docker container, and we can actually build all of our main configuration inside that container, and within that actual Docker image or Docker container that we have, it actually deploy the image and has all of the right configuration. So if we're actually utilizing containerization, step 2 and 3 can be merged into one. So that will leave us with only 2 steps, which is a way better approach than having all of those steps that we have mentioned before. If you'd like to learn more about Docker and containerization, I have a video which I'm going to link it on the upper right hand side corner, which you can actually go check it out, and how you can build ASP.NET 5 application with Docker. So what's the benefit of infrastructure as code? The main benefits of infrastructure as code is bringing development and ops together. So what does that mean? So it actually means that the developers will be able to understand how the infrastructure works. They will be able to understand what are the requirements of those servers, how they are being configured, what are the configuration that they needed, what are the dependency that the servers are utilizing, and it will also allow the operations team to actually understand how the application is booting up, what are the services that is required, what are the dependency of that application, what are the order of those dependencies. So once they are actually deploying it in the live environment, they can actually have a much better overview about how this application is being handled and how this application is running. So that way we are bringing developers and ops together, and it will bridge that gap between the two, and it make them more close together. So developers will be understanding how the operations work, and the operations will know how the devs and the applications actually built. The second point is consistent infrastructure configuration. So that means that once we have built this IAC once, we can deploy it anywhere we want. So for example, we can deploy it on our development server, we can deploy it on our QA, on our production, or our A/B testing, all of those environment that we want, and it will be consistent every single time because we are using the same exact configuration. Since we're utilizing code here, it means that it's very easy for us to just duplicate it on any environment that we want, and we can see the same result every single time. So that's where the consistency comes from. The second step is faster deployment, because once we have already built the infrastructure part once, which is the coding part once, we don't really need to waste time to doing it again because the code is already there. So every single time what we need to do is just pull out the source code that we have for deployment and actually just deploy it instead of doing all of the steps that we have mentioned earlier manually. The third step is documentation, because since we are utilizing code, it's way easier for us to document code and document the processes we're taking than actually going through all of the manual steps and writing documentation for every single steps and how they are actually being handled. And for example, if someone did not actually document the code, it will be much more easier for us to go through the code, understand and document it, than actually going through a server and trying to understand what's happening on that server if it's being done manually and documented from there. And the final points that I want to mention here about benefit is traceability. So in case something is going wrong, something is needs to be changed, something is not actually working as it should be, we can actually trace back the origin of the problem directly to the infrastructure as code where it has been deployed. So let's say, for example, we created a DB server, and that DB server, for example, was running on version 12, and we need it to at least to be version 14, and the application is not actually accepting to connect to that server because of version 14. So we can actually go directly there to that infrastructure as code, check how it's working, check the configuration that we have, and we can actually build it from there. Check if there's any changes that has been done, or if it has been downgraded from 14 to 12, and so on and so forth. So it will allow us to trace all of the changes. It will allow us to see the history, and basically from that point forward, it will allow us to basically understand all of the changes that has been done and actually understand how things are done and why they are being done in a certain way. So these are some of the benefits of IAC. There's a lot more of them, but these are, I think, the main ones that we need to focus on. The next step is we're going to be discussing the process. So the process here is when it comes to infrastructure as code, this is basically the entire process that we're going to follow. It's going to be starting with developing our application until it's being running on the server. And this image right now here, or this chart right here, is going to illustrate the actual process that we're going to be utilizing in this video. So we're going to be starting by developing our application locally. We're going to be actually then committing it to GitHub, and which is basically our source control. And once we commit it to GitHub, we're going to be actually directly building a Docker image. And once we build that Docker image, we're going to publish it to Docker Hub. And once we publish to Docker Hub, we're going to utilize Terraform to automatically create the infrastructure for us if it's not created, and then actually deploy that image into our Azure. And from that point forward, we can actually run the application. So the process basically is treating the application from pure source code to actually running on a server, all based on code without actually us going through all of the configuration manually. And for that, we're going to be utilizing different tools and services. We're going to be utilizing GitHub, Docker, Terraform, Azure DevOps, and Azure. So we're going to be discussing all of the ingredients and accounts in the points after this, but I want us to understand here what is the process. So the process will always start by development. So we're going to be creating our application locally and making sure that it runs locally, and all of that configuration on all of the application is available locally and developed locally. Once that application has been created and it's run locally as it should, then we commit it. The next step for us is to commit it to our code repo. Once we commit it to our code repo, we're gonna initiate an action. And that action that's going to be initiated is to actually build our application for us. And once it builds our application for us, it will generate a Docker image. And once that Docker image has been generated, it will be published to Docker Hub. And Docker Hub basically is the repository for Docker images. There's a lot of images there that we can actually utilize, which is provided by companies like Microsoft, like Oracle, like Node, for example, and we can utilize them from there. So once we have deployed our image, our Docker image to Docker Hub, what we're going to be doing is we're actually going to be provisioning the infrastructure if we didn't do so already. And once we have provisioned that infrastructure, we're going to be deploying the image that we have created to that infrastructure, and then we're going to be actually running that image. So we're going to be referring back to this chart during our code, but for now I just wanted to go on overview about what are the steps that we're gonna be doing and how everything fits together. So what are the ingredients that we need? So we're gonna be needing Visual Studio Code, which is our code editor. We're gonna needing the .NET 5 SDK. We're gonna utilize Terraform, Azure CLI, and Docker. You can find the links on the screen right now as well. I'm gonna be adding them in the description down below. So these basically are the ingredients, or basically the software we're gonna be utilizing. But we need also some accounts that we can create. So the accounts we're gonna be needing, we're gonna need an Azure account, which if you register now for Azure with a new account, you'll get a $200 for a year, and there's a lot of free services that we can utilize. Even if you have a current subscription, it will not cost you much. I think maybe like a few cents within a month with the services that we're actually going to utilize. But I highly recommend that you actually delete those services after you create them in this video, so you don't incur charges. But even if you do, it's going to be very minimal charges. The next step is we need Azure DevOps, which is a free tier, and you can find the link here or in the description down below, which is the Azure DevOps. With the Azure DevOps, we're going to be actually utilizing the Azure pipelines to help us manage all of those, as well with GitHub, which is going to be our code repo, as well as Docker Hub. We're going to be able to utilize it in order to host our Docker images. So now let's get coding. So after installing all of the tools and dependency that we have, the first thing that we're going to be doing is checking the .NET Core version that we currently have. In order for us to do that, we're going to be utilizing the .NET dash version. So inside our terminal, we're going to put .NET dash version. And as you can see here, I have version 5.0.300, which is the latest version by the time of this recording. If you have any other number, that should be fine. If you have any error, please re-download and install the SDK all over again. So the next step for us is we're going to be creating our application. So let me create a folder and we'll put our application there. So we'll go to the desktop and make we'll call it infrastructure as code. And let's navigate to it. And we'll create my application. For that, we're going to be utilizing the .NET new keyword. So it's going to be .NET new web API. And basically, we're just going to give it a name and we're going to call it sample API. Great. And this should take a few seconds. Great. Now the application has been created. Let us open it up in Visual Studio Code. Great. Now that we have our application opened in Visual Studio Code, let us just make sure that it builds and runs successfully. So in order for us to do that, let's go to the view and open our our terminal. And from here, let us type .NET build. And we can see it's building, and build succeeded, and .NET run. Okay, perfect. We can see the application is running on port 5000. Now let us open it in our browser. And let's go to localhost 5000, and I think what's the controller name? I think the default one is weather forecast. Yeah, let's take that. And as we can see, we are getting the response back from the server correctly, and we're getting our JSON array. Perfect. So this means that our application is running as it should be. Let's stop our application, and we're not gonna be doing a lot of changes here. All we're gonna be doing is just creating a new sample controller, which is gonna be returning a list of names, and then we're gonna be adding our Docker file. So the first thing we're gonna be doing, let's make this smaller. Let us delete this. We don't really need it, so delete. And let us delete this controller. I'll tell you what, let's create a new controller, new, and we'll call this controller, let's call it person controller. And basically we can take this, let's take these, and let's take this as well. Let's fix those references. Perfect. And let us take this cat. And that's all. And then after that, we're just gonna be deleting the other one. We don't really need. So here we're gonna return an iAction result. We don't really need any of this. For now, we're just gonna put return OK, which is basically a 200. And let us delete this, delete. And inside our persons.controller, let's create a sample array. So put var persons equal, let's put a new, and here we're just gonna put, so Mohamad, let's say Donald, Duck, say Mickey, we can put Batman, and we can put, for example, Thor, and lastly let's put Tony Stark, for example. Okay, once we have added all of those, now we have to return it. So all we need to do is just return persons. Great. Now let's run the application. If I tell spinit.net build. Great. Now .net run. And let's go back to our browser. And instead of weather forecast, it's gonna be persons. And we can see we have our array returning as it should be. Perfect. So now we did some minor changes to our application, and we basically make sure it's running. So the next step for us is basically we're going to be creating a new Docker file, and that Docker file basically is going to be packaging our application into a Docker image. So let's do that. Inside our root directory, let's create a new file, and we're going to call it Docker file. Great. So the first thing, thank you, inside here we're going to be basically getting the base image. So if you want to learn about Docker file and how you can create them, I have a dedicated video on how you can build Docker files and Docker images with ASP.NET Core applications. I'm going to be linking it on the upper right hand side corner here. You can click on it and follow that. For now, I'm going to try to explain it as I go, but in that video I'll delve more into details of how is it built this way, why are we doing it, and so on and so forth. So first of all, we're gonna be putting the from keyword, which is basically gonna specify the base image, and we're gonna be utilizing the mcr.microsoft azure.com/.net/SDK, and we're going to be utilizing version 5.0 as a build environment. Great. So once we have done that, the next step is we're going to specifying the work directory. So the work directory is where all of the code is going to go into inside this build environment. So we took the images directly from Docker Hub, and then we created a folder inside that image, and then we're going to be basically copying our CS proj from our current directory, which is on our machine, to that new image. So CS proj, and then we're gonna be basically copying it into the root directory, and that we're gonna be running the .NET restore, and basically that we're gonna be restoring all of the packages inside the CS proj. And once we have done that, we're gonna be copying all of the rest of the files inside that new Docker image that we have, and then we're gonna be running .NET. Basically, we're gonna be publishing the application inside that image. So publish -c, and we'll have to put the release keyword, and we're gonna make it inside the out folder. So here we have to put an O, and then we put it inside the out. So here we're publishing the application inside this build environment that we have created, and then we're gonna be building our last image. So mcr.microsoft.com/.net/SDK, and also 5.0. We're gonna specify a work directory, and it's also gonna be up. And basically what we're gonna be doing is okay, let's expose port 80 because we're gonna utilize it, and then we're gonna copy everything from the build environment that we have. So from the build dash environment into the new one. So we're gonna go into the build environment, we're gonna go to the app folder, to the out, we're gonna copy everything from there into the root directory of this new environment that we have, and we're gonna specify the entry point of our application. So once our Docker image run and the container is created, what are the commands that they're gonna be executing? And for us, it's gonna be .NET. We need to put quotations, and basically it's gonna be sample API .dll. Let's see. Yep, sample API.dll. Great. So now let's test this out. So let's build this Docker image. So how do we do that? We're gonna be utilizing the Docker keyword. So Docker, we're gonna use the build keyword because we're gonna be building it. We're gonna tag it. So the way we're gonna tag it is we have a certain format, which is I'm gonna be explaining to you right now. And dot. So basically, we need to put first the Docker command, the Docker keyword, and then we need to put the Docker command, which is build, and then we need to put -d, which is gonna be basically we're telling it that we need to tag this image. First, let us not tag it so we can see what happened, and let's see when we tag it what happens. So that way we can understand why we're doing the tagging. So now all we need to do is just we're gonna building this image, and the reason that we put a dot here, so we're telling this build command where to find the Docker file, and when we put the dot, it means that you can find it in the root directory. If we had it inside the folder, we can specify it, but because it's in the root directory, we can put a dot. Now let's build this. This should take a few seconds because it's a fairly straightforward application, nothing really complicated. And we can see right now that the build has been completed, an image has been created, and basically this image has got this ID. Because we did not tag this image, we don't really know, we cannot really refer to it directly unless we memorize this ID and we write it somewhere and we can refer to it back, which is not really feasible. When we tag it, so let's now write it again. So Docker build -t, t means we are tagging it, and we're putting /sample API. And as you can see here, I have put firstly my first name and last name because these are my Docker accounts. This is my account on Docker Hub, and sample API is the name of the application that I currently have. So because I want to push it to Docker Hub, it's a good practice to put your your Docker Hub username, and then you put / then the application name, and then after that you just put a dot. So now let's see what happens when I do this. You can see that after the image has been exported, the image has still been exported with the right image, but you can see here it also has been named directly after my account. So Mohamad Lawan / sample API. I think I forgot the A, so let's do it again. Great, sample API. Perfect. So now I have this. Let us now run it. So before we do that, I want to specify a port inside my application so I can directly connect to it. So inside the web builder .use URL, and basically it's going to be HTTP. This needs to be like this, HTTP : / and we're gonna force it to connect to port 80. And let us rebuild that image again, because we forgot to do this before that. So now every time you do any changes to your application, you need to rebuild the image so you can have the latest version. So now that we have done that, now let us try to run the application. First, let us utilize the Docker keyword because we want to run it. Then we need to specify which command which is going to be running, and then we need to specify which port. So we put -p, and we're going to be connecting to this Docker container from port 80 on the outside to port 80 on the inside, because we have specified, because basically this Docker image is going to be turning into its own Docker container, and this Docker container is going to run the web server inside of it. And we have specified that the internal web server inside this container is going to be running on port 80, but when we are going to be connecting to it from the outside, the way we find this container out of all of the other containers is we're going to be connecting to port 8080, but once that connection hits port 8080, the container will automatically route the traffic from port 8080 to port 80. So that way we can have a lot of different containers running at the same time, and we don't have really any conflicting ports to connect to them. So this is why port 8080, we're connecting to port 80, and then basically we need to specify the image name, and basically we specify that we gave it the same name as before. So Mohamad Lawan / sample API. And now if I click on enter, we should see the application building, and it's running on port 80. So now let's go back to the web browser, and let me open this as a new tab, and instead of having it running on port 5001, let's put 8080. Okay, one more thing that we need to do before we do anything else, which I forgot to do, is inside our startup class, all we need to do is we need to disable HTTPS. So let's save this, let's disable this, and let's rebuild our image. So we can put docker build -t Mohamad Lawan / sample API. This should take a few seconds, because basically we're rebuilding the entire image. And once we have done that, now let's try to run it again. So let's put docker run -p, and we're gonna go to port 8080, and we're gonna connect to port 80, and then basically we're gonna specify the image name, which is Mohamad Lawan / sample API. And now we should see the application running perfect. Now let's go to our web browser, and instead of 8081 here, let's put 8080. Let's see, still utilizing okay. Let us clear all of the images. So it's not even okay, it's running here. Let's stop it, and let us remove all of these images, and then basically we'll have a fresh plate to start from. Okay, let us rebuild the image. Now let us run it again on port 8080. And let's go to our browser and refresh. It's still giving us an SSL error. Let us try to run it on a different port, maybe 8081. Okay, great. So the main issue was there was a dangling image when I was trying the code before actually recording this video. It was stuck on port 8081, on port 8080. But now that we have changed to port 8081, it worked. Okay, great. Now that we have sorted this issue out, now that we have made sure that everything is working and we sort the issue out with SSL, now let's push our code to Docker Hub. So we're gonna be logging into Docker Hub and we're gonna be pushing the code that we currently have there. So what are we gonna do right now is we're gonna actually push the local image that we have created, and we can see so we can see it here within Docker Hub. So in order for us to do that, let's go back to Visual Studio Code. And we need to type the following command. So the first one, we need to utilize a Docker command, then push, because we're going to be pushing the code, and basically we need to decide what image are we going to push. So we have named it Mohamad /sample API. And basically right now this is going to be pushed into our Docker Hub repository. This shouldn't take a lot of time, so let's wait for it. I'm gonna forward this video until this is finished. Okay, great. Now the image has been pushed successfully. Now let's go back to Docker Hub and let's refresh. And as we can see here, we have our image has been uploaded a few seconds ago. If we go to it, we can see that this image has been uploaded and it has the latest tag available to it. Great. So now that we have done that, the next step is we're gonna be creating a Git repository, and we're gonna be actually adding first our git ignore and then initializing our git repo and then pushing it to GitHub. Great. So let's start doing that first. So first let's come to GitHub and let's create a new git repo, and for the sake of it I'm gonna call it sample API v2. We're gonna keep it public. Let's keep this license as Open Apache, and let's create it. Perfect. So the next step for us is we need to find the git ignore list. You can directly Google it and you can able to find it. So Google and first what we need to do is so let's put git ignore for ASP.NET Core. Okay, I see this one. Yeah, that seems good. Great, let's copy this. And let's go back to our Visual Studio Code, and here let's create a new file, and this file we'll call it .git ignore, and let's paste this here and save it. Perfect. So once we have done that, now we need to actually initialize our git repository here. So inside the terminal we're gonna type git init. Great. Once we have done that, the next step is we need to add all of those changes that we have to Git. So put git add. Great. And the next step is we need to commit this. So let's commit this. Git commit -m. I'll call it initial commit. Great. Perfect. So now we have committed this. The next step for us is to actually add the owner repo to here. So let's go back to our web browser and to our newly created repository. So now let's take this URL and let's go back to Visual Studio Code. And let's type this here. So git remote add origin. I will paste the URL that we have here. Great. To verify that it worked, let's do this. Git remote -v, and we can see it has it is linking to the online URL. Perfect. So the next step is we need to push it. So the way we do that, it's gonna be git push -u origin to, let's see, let's copy this and let's paste it, and let's see. So we enter the password. Great, now it has been pushed. Now let's check our web browser and let's refresh it here. Perfect. Now the goal that we want to reach is actually once we deploy our code to once we push our code to GitHub, what we want to do is we need to initialize a Docker image build. So as soon as we push here the code here, a Docker a action should be initiated and our Docker image should be built. And once that image is built, it's automatically uploaded to Docker Hub. And once that image is uploaded to Docker Hub, it is actually then an infrastructure is initiated, and then that image has been deployed to the infrastructure that has been initiated basically on Azure, so we can actually execute it. So what we did right now is we actually accomplished the first step of our journey, which is actually creating a Git repo and pushing the code to it. So the next step is we're gonna be exploring Terraform and actually creating our Terraform file in order for us to start versioning our infrastructure and actually utilizing it for managing our infrastructure. So what is Terraform? Terraform is a programming language that has been created by HashiCorp, and basically it is a language that allows us to communicate with the cloud provider APIs, and from there we can actually create, update, delete resources as we need. And it's a very powerful tool, and let's check their website. So it's terraform.io. And from here, you can go through it and it will give you a lot of information of how it works, how it communicates. But the main concept of it is like a unified language that we can utilize. Basically, we specify to which cloud provider do you want to utilize. Do we want to use Azure? Do we want to use AWS or Google? And once we have specified that, there are certain languages or certain keywords that we need to utilize, so it will make it compatible with that cloud provider. And basically once we save it and actually initialize it and run it, that language is automatically translated into something that the cloud provider will understand. So for example, if we want to create new resources on Azure with a dedicated web app, and if we input the right commands for it, the code that we input in Terraform will be automatically translated, and it will be compatible with Azure. So you can tell me, why don't we use specific cloud language? So why don't we use, for example, directly the Azure CLI in order for us to create this? The reason behind this is compatibility. So if let's say, for example, we have built our entire infrastructure within Azure, within Azure, and let's say down the line in like a few months, we decided, we need to move everything back to AWS or Google, or we want to make it run in a different cloud provider completely. So in order for us to recreate everything and just not make it only cloud provider specific, so we can utilize Terraform, just change the providers and change minor configuration, and we can actually basically just all of the hard work that we did and all of the configuration that we did can directly be migrated to different cloud provider without the headache of actually trying to see how are we gonna actually migrate from purely from PowerShell and Azure CLI to different cloud providers. So to give us the flexibility to experiment, to move, and actually to make our code last longer and actually more reusable. So there's a couple of things that we're gonna be needing here. In the download links, at first I already provided the link to Terraform, but if you haven't already downloaded it, you need to go to terraform.io/download, and you need to download the right one based on your operating system. As well, you need to download the Azure CLI. So let's download it. So Azure CLI download. So as well here, the installation process is straightforward depending on your setup. So I'm using macOS, so you can use Homebrew in order for you to do all of those installations. Great. Once you have downloaded all of these, now let's go back to our Visual Studio Code. And inside Visual Studio Code, what we're going to be doing is we're going to be creating a file inside our root directory. And this new file, we're gonna call it main.tf. And basically the F stands for Terraform, and main, we just give it the word main. Great. So now we can see we have a new file created, which is a Terraform file. So what are we gonna do now? Basically what we're gonna be doing is we're gonna be actually start initializing our Terraform project. So how do we do that? We start with our Terraform, which basically we need to specify here the provider that we're going to be using. So let's add comments as we go so we can understand what we're doing. So basically we're gonna that we are going to use, and then once we specify the word Terraform, then we're gonna specify here the provider. So it's gonna be required providers. And then we're gonna specify that we're gonna be using Azure RM, and from that here we need to specify the sources. Basically we're gonna be utilizing the HashiCorp version of Azure, so we're gonna put the source. Great, and then we need to specify the version of which version of HashiCorp we want to utilize. So I think we can utilize 2.46.0. Great. So what we did here, basically we initialized Terraform. Then we, as we said, we need to specify which cloud provider we want to utilize. So let's add a comment here. And then basically in order for us to say Azure, we need to utilize the Azure RM, and then here we specify which version of it we can we gonna be using and what's the source of it. All of these you can find on the, for example, for AWS, you can go Google Terraform provider for AWS and you will get the same source code here. I already did that for Azure, so that's why I already know it. So once we did that, the next step is we need to actually initialize the provider. So how do we do that? So let's add a comment here, initialize the provider. So it's very simple. We just put a provider, and as we said, it's gonna be Azure RM, and let's keep the feature right now empty. So yeah, so put features. I will keep it empty for now. So basically here we're just you can think about this as like an initialization. It's like a constructor in order for us to initialize all of the providers that we want. Great. So once we have done that, the next step for us is we want to create a resource group. As you know, everything within Azure needs to be inside a resource group. We cannot create anything without having a resource group first. So basically all of the services that we're going to be utilizing on Azure, if it's going to be, for example, a Docker container manager, or for example, if it's gonna be an app service, a database, networking, all of those needs to live inside a resource group. So we need to create a resource group. But how do we do that? We're gonna basically utilize some Terraform here also to create it. Okay, so let's start, because we're gonna be creating a new resource on Azure, so we need to utilize the word resource. And basically here, as you can see, we have a list of all of the available resources for Azure that we can utilize. So what we're gonna be doing is we're gonna put Azure RM underscore resource underscore group. And basically right now we are creating a resource group, and then we need to specify a name. So basically the name here is not the actual name that's going to be reflected on Azure, but the name here is basically going to be the ID that we're going to be for within Terraform files. So if we want to refer back to it, we can utilize this name here. So for this reason, we're going to call it Terraform underscore resource group underscore sample API. Great. So once we have done that, let's add these comments here so we actually know what's going on. So we are creating a resource group in Azure. Let's put the comment about the name on line 21 is not reflected on Azure, rather it is used in Terraform. Great. So once we have done that, now we need to specify the information of this resource group. So basically we need to specify a name, and this name actually it's gonna be the one that's gonna be reflected on Azure. So I'm gonna call this one Mohamad Lawand Terraform resource group, and then we're gonna specify the location for it, so under which data center we want to utilize. So we're gonna utilize the UK South one. Great. So now what we did here is we have created a resource group. We specified it. So this is the ID that we're gonna be referring to it inside Terraform, and this is what we're gonna see when we actually deploy it to Azure. And here we specified the data center. So let's add the comments here. We're gonna say this is the name on Azure, and this is gonna be specify the data center. Great. So the next step is basically before actually we stop into that, let me just give you an overview about a nice extension that you can utilize. So if you go here to your extension and you can type Terraform, you can actually see that I have installed a couple of extensions. So this is the official, I think, no, that's not it. So this is a Terraform extension that helps you with IntelliSense. As well, this is the official Terraform extension that existed. Also help you with IntelliSense, with the autocomplete and all of those. So I think these two are really good. If you find any other one, please add them in the comments down below. But I think these two are doing a pretty good job. Okay, great. So after we have done that, another point that I want to discuss is the location. So the locations here, it's very easy for you to find it. You can actually Google a list of locations, Azure location you can add, or you can utilize the Azure location provider. So after you have installed the Azure CLI, what you can do is you can put Azure account list dash locations, and basically now we're gonna get a JSON with all of the available locations that Azure supports. So because I'm not actually currently logged into Azure on my machine, I won't be able to see it, but let me log in, and then based on that we can see it, and then I'm gonna log out because I want to show you different stuff, so it's better to be logged out. Terminal here we can see that has automatically logged in. Great. So let us execute the command again, which is Azure account list locations, and we can see here that we can see a JSON file which contain all of the Azure locations. So this is another way we can actually use in order for us to see which available location that Azure provides. Great. So once after that, let's log out again. So Azure logout, and we have logged out. Let's make sure that we're not logged in. So if we execute this, perfect. So the next step is we need to discuss how Terraform actually works. So Terraform has three main commands. I'll tell you what, there's actually four main commands. One of them is not actually required when we want to deploy, but it's good for us as developers to see what's going on. So now let us discuss the four main commands that Terraform provides. So we can see here that Terraform supports four main commands, which is init, plan, apply, and destroy. So the init command basically initialize our Terraform locally and basically download any, for example, connector that it needs based on our cloud provider. So if, for example, if we're going to communicate with Azure, it gets the connector for Azure, AWS, Google, so on and so forth, and then it's configured our machine locally or our Terraform file for that project locally, so it will be able to communicate with that cloud provider. So once we have done that, the second step, which is not really required to do, but it is good for us as developer to do, which is plan. And once we click on execute the plan command, basically it shows us the execution plan. So it actually shows us the steps that's going to be created. So let's say we're going to create a container registry on Azure. So first we can see it's going to be creating the resource group, and then it's going to, for example, configure the networks, and then actually it's going to create the container registry. So we're going to show us a plan. If there's anything not right with us, we can actually fix it directly from there rather than actually deploying it and trying again. So that's the benefit of the plan. Once we are happy with the plan, we can actually apply it. Once the apply command, basically it takes all of the changes that we have, all of the Terraform commands that we have, and actually apply it against Azure. So against our cloud provider. So for example, it execute all of the commands that we have seen within the plan steps into the cloud provider. So once we have done that, it will give us a confirmation that it has completed successfully. And the last one, destroy, as you can imagine, is basically removing everything that we have just created, and basically we're having a clean sheet. So in order rather than us going into the Azure portal and trying to delete everything manually step by step, the destroy it tracks all of the changes that we have. So it tracks that we have, for example, a resource group, a container manager, and some networking stuff. So it will go in and delete them step by step and make sure that they are all cleaned out of our cloud provider. Great. So basically these are the four steps. What we're going to be doing right now, we're going to be actually executing the first two so we can see how they work. And after that, we're going to be delving more deep into Terraforms. So inside Visual Studio, first let us save the changes here inside the Terraform file. And inside our terminal, let's type Terraform init. So basically this is the first one. Basically currently we're just initializing the Terraform, and as you can see, it says it's initializing the backend. Basically it's initializing Terraform for this project, and we can see there's a new folder which is created.terraform, and then we can it's actually getting the providers based on the configuration. So since we have specified it's gonna be an Azure provider, so it got all of the Azure connector and downloaded them and installed it inside our project. And then basically it created some kind of session manager for Terraform, because it's going to be actually communicating with the cloud. And once that, it gave us a confirmation that everything is running as it should be. One thing I like to do is I want to add this folder to the git ignore list. So let's open our .git ignore and let's add it anywhere. Let's add it here, just to be, can add it here at the end. So we just here Terraform, because we don't really want to push those into our Git repo. So let's put it here, .terraform. Okay, great. So now this file will not be pushed into our Git repository. Great. So the next step that we're going to be doing is, as we said, we have the init, we have the plan, we have the apply, and we have the destroy. So because we want to see what's going to happen, so let's go to with the plan. So it's going to be Terraform plan. And right now we're going to get an error. Well, I hope so we're going to get an error. So the reason I didn't get an error because I have already configured my terminal, which was an extra step that we're gonna go through in order to communicate directly with Azure. So we're gonna utilize the Terraform plan. Terraform plan. And this should take a few seconds. And then we should see a list of planning that's gonna be executed against our cloud provider. Great. So now we can see here that basically there is one action that's going to be executed, which is basically creating a new resource group. And we can see here there's a create keyword, and basically it specifies the name of our resource group, the location, and the ID basically is going to be generated after the apply. And you might think to yourself here, like, how did this happen? Basically Terraform specified a plan for us, and it summarized it by having a plan, one to add, 0 change, 0 distort. So basically it decided on what we currently have inside our Terraform farm. There's going to be one file that's going to be added, a new resource group that's going to be created. We're not changing anything, and we're not destroying anything. So for this reason we get our plan summary, which is 1 add, 0 change, and 0 destroy. So let us do the last step and actually apply those changes. So let's see how that's gonna work. So Terraform apply, and this should take a few seconds until the communication between our local machine and our cloud provider. So it says here that all of the connection has been set up. Do I wanna continue? So I will type yes, and this should take another few seconds to execute because it's fairly minor change. And once this is done, we can see it has communicated with it. It has started to creating, then it has created successfully, and then basically we have the green confirmation that everything has went to plan. So now let's open our Azure portal. And you might think to yourself here, like, how did this happen? Basically Terraform specified a plan for us, and it summarized it by having a plan, one to add, 0 change, 0 distort. So basically it decided on what we currently have inside our Terraform farm. There's going to be one file that's going to be added, a new resource group that's going to be created. We're not changing anything, and we're not destroying anything. So for this reason we get our plan summary, which is 1 add, 0 change, and 0 destroy. So let us do the last step and actually apply those changes. So let's see how that's gonna work. So Terraform apply, and this should take a few seconds until the communication between our local machine and our cloud provider. So it says here that all of the connection has been set up. Do I wanna continue? So I will type yes, and this should take another few seconds to execute because it's fairly minor change. And once this is done, we can see it has communicated with it. It has started to creating, then it has created successfully, and then basically we have the green confirmation that everything has went to plan. So now let's open our Azure portal, and let's go to resource groups, and this should take a few seconds for it to appear. What did we call our resource group here? Mohamad Lawan TF resource group. So we should be able to see it here, and we can see here that Mohamad Lawan TF resource group has been created for us, and it's empty. We didn't specify anything else, but we can see that it has already the location UK South embedded into it. Okay, great. So once we have done that, now let us explore one point that we want to discuss. So you might think to yourself, how did this happen? Like, I did not log into Azure. As you saw, if we go, for example, Azure logout, or for example, if I try to execute the Azure location command, so Azure AZ account list dash location. It's gonna show me that I'm signed out. I'm not actually logged in into Azure, so there is no way for it to be able to communicate. So yeah, list locations, sorry. It's gonna show me that I'm signed out. There's no way for it to communicate. But how did Terraform knew that it has access to my resources? Because I already gave it permissions, and those permissions I have already enabled them into my system variable. We're gonna go through how we can set them up, but don't worry, Terraform does not have like a secret weapon where it will be automatically connect to your provider from your machine. You need to specify those credentials. I have already specified them on my machine, and then I'm gonna show you how you can generate them, and then you can add them to your own machine based on the operating system. So for Windows and Mac and Linux, it's gonna be separate for each. So for now, I just wanted to highlight that just because I executed here and work without actually doing any further configuration, I have already configured my system to have some Terraform credential embedded in it. Great. So once we have done that, the next step is we're gonna be actually updating our Terraform file to have more stuff in it. So now we're gonna be actually creating a container resource group. So after the resource creation, so let's add a new one, and we're gonna give a command create the container group, and here we're gonna put resource, and we're gonna be utilizing the Azure rm underscore container underscore group, and we're gonna basically give it a let's put it simple word, Terraform container group underscore sample API. Okay, great. So now that we have, so as we said earlier, this is the name that we're gonna be actually referring to from within Terraform, so it's not the one that's gonna be reflected on Azure. The next step is we're gonna be specifying the name, and we're gonna call it container group underscore sample API. So this is the name that's gonna be available for us on Azure. Then we need to specify the location. So the nice thing about it, so we don't really need to specify the location all over again. Let's say here it's very simple, UK South, but let's say we are managing different data centers. We don't really want to like manually type it. What we can do is we can refer to a resource group that we have created and take the information from there. So because here we have already created a resource group, a sample API, TF-RJ sample API, we can utilize this. So how do we do that? It's very simple. We're just telling Terraform here to what's the resource that we're going to be utilizing in order to get this information. It's going to be resource rm underscore resource underscore group, if I can type. And then after that, basically if I put a dot, I just want to specify here the ID, which is this ID that we have here. So it's going to be TF underscore RJ underscore sample API. And after that, basically I just want to get the location. So we put dot location, and we'll automatically inherit this location here into this location here. So it's going to be UK South. Similarly, I want to do for the resource group name, because every container group needs a resource group. So we're going to put resource group underscore name. Perfect. And then I'm going to do the same thing, which is going to be Azure rm underscore resource underscore group dot tf dot rj underscore rj underscore sample API dot name. Great. So once we have done that, there is more configuration that we need to add. So let us just do some alignments so it will be easier for us to read. Okay, great. So we can see here basically they are all the same until the location and name. So the first thing configuration that we're going to add is the IP addresses for our resource group. So we're going to put IP underscore address type, and we're just gonna make it public because we want to be able to communicate with it. And then the next step is we're gonna be specifying the DNS name. So we're gonna put DNS name label, and we're gonna give it as simple as sample API Terraform. Great. Once we have done that, then we're gonna specify the OS type that's gonna be hosting our containers, and we're gonna of course we're gonna specify Linux. It's cheaper and easier to maintain, and it's compatible with more stuff. Okay, perfect. Now once we have done those, the next step is we're gonna be basically building the container information. So after we have built the container group, we are gonna tell this resource group that it needs to actually pull an image from Docker Hub. So how are we gonna be doing that? So we need to specify here the container, and basically because we have made the container into Docker Hub a public container, anyone can actually pull it in without doing any authentication. So let us just go back to our Docker Hub so we can review that. So this container image that we have created here, which is Mohamad Lawan sample API, this is a public image. So I don't need any credentials, anyone can see it, and it's available publicly for anyone to see. So for this reason, we are able to directly utilize it from Azure without actually providing any authentication within Docker Hub. So let's go back here and add this, and we can see how this will work. So we specify the container, and then basically we need to give it a name. I'm gonna give it sample API, which is gonna be the name for it. And after we have done that, we need to specify the image that we're gonna be pulling out from Docker Hub, and as you can see, the image name is this one. So let's copy this, and here we can put the image equal, let's fix those spacing. Great. So once we have done the image, the next step is we're going to be specifying for this container is specifically how many CPUs that we want. So basically I just want one CPU to be available, so equal to 1. I want how many RAMs do I want it available, so the memory also is going to be 1 gigabyte. And lastly, I want to specify the ports that will be able to communicate with this. So for that, we're just going to be making ports 80 available. So basically we are exposing port 80. Yes, so here we have to specify which protocol, and it's gonna be simply TCP. Perfect. So now that we have this ready, let us try to execute it again. So, and how do we do that? Basically we just need to plan again. So we put init, Terraform init, and this should take a few work, and I started to initialize it. So Terraform plan. Now this should take a few seconds as well, but it will give us like a list of the plans that's gonna be utilizing in order for it to deploy these changes to Azure. And as we can see here, we have the list has been populated, so we can see that the ID, the IP addresses, and all of those is planned to be created, the restart policies, the OS type, the container, and all of basically the information, as well as the identity providers. And we can see here it's planning to add one more resources on top of the resource that we have. Great. So the next step is we're gonna be implementing this and seeing if it's actually gonna create it for us. So how do we do that? You guessed it right, it's gonna be Terraform apply. And this should take a few seconds, and it's gonna prompt us, do we really wanna continue to execute this? And we're gonna say yes. And another few seconds after that, we should get a confirmation message that everything is working as it should. And as we can see here, we can see that Terraform started creating our container group sample API, and it says it's still creating. It's not because basically after it creates the resource group, it's gonna connect to Docker Hub, it's gonna pull that image from Docker Hub, and it's basically will allow us to run that image that we have from Docker Hub inside our application on Azure. Let's just wait until this is finished and I will resume. So now as we can see, it has completed successfully, and we can see that there's one resource that has been created. And if we go right now to our Azure portal, and if we go inside the newly created, not newly, the one we created before, we can see that we have our container group sample API has been created. And if we open it, we can see that the name that we have given it is already available for us. And if we go to containers, we can see that it has already pulled the Mohamad Lawan sample API container from Docker Hub. Perfect. So now if we take this link and let's open it in a new tab, and I think it was persons. Let's double check from Visual Studio Code. Yes, it's persons. So as you can see here that we have the JSON available for us, so which means the container has been pulled successfully and we are able to utilize it. Great. So now that we have configured Terraform to actually execute all of the commands that we want for us and actually connect to Azure, create the new resources, basically create new container group, communicate with Docker Hub, pull down the image from Docker Hub, and actually running that image, we can see that we have basically the Terraform part is ready for us to utilize. But right now what we're gonna be discussing is how are we gonna let Terraform communicate with Azure, and how is this happened. So the way there was two ways that we can actually authenticate Terraform with Azure. So let's go back to Visual Studio Code. And the first way that we could have utilized it is using the Azure login, which basically allow us to log into Azure through our terminal and have all of the credentials ready and embedded within our terminal. So this is a good case if we are actually only developing locally. But if we're gonna automate the entire process, so every time we actually push code, the application will actually know what to do. So where to get the information, what's the client ID, what's the secret, and all of those information. Now, how are we gonna let Terraform communicate with Azure? We need to utilize something called the service principal. So service principles is like an automated user that we can create from Azure, and basically that user will have credentials to execute any command that we want against our Azure subscription. So that service principal will give us, for example, the client ID, the client secret, the tenant ID, and the subscription ID. And from those points, the service principal will actually empower Terraform to act as if a user is actually executing all of those. So right now on my local machine, I have the service principal installed, but basically we're gonna be going through how are we gonna be able to generate them, how are we gonna get the service principal, and then basically from there we were gonna be enabling them inside our system, and then we're gonna be enabling them in our pipelines. So I would just likely to I just want to really highlight one single point, which is this is really important information and highly sensitive information. So anyone who has access to the information that we're going to generate, which is the client ID, secret, tenant ID, and subscription ID, will be able to utilize all of the information that you currently have within Azure, and they will be able to execute any command and access any resource that you have. So be very careful of all of this information. Consider this as a warning, because it's really important for you to understand that these information are really sensitive and you shouldn't basically share them. So the first thing we're going to be doing is we're going to be going to Terraform website. So let's go to our web browser. So as you can see here, we have the Azure CLI that we can utilize to authenticate Terraform with. We have managed services, but we're going to be focusing on the service principal with a client secret. So here, if you go through it, you will be able to see how you are able to generate them, and how actually you will be able to specify or utilize all of them in order for you to generate. So what I'm going to be doing right now is I'm gonna going through Azure portal and actually going through the step of generating service principal with you, and basically from that point forward we are able to check all of the steps that we need in order to generate these 4 points. So if we go back to Visual Studio Code, I'm just gonna specify here the 4 items that we're going to be needing, and so we can fill them one by one. So the first thing we're going to be needing is we're going to be needing the client ID, and then we're going to be needing the client secret, and then we're going to be needing the tenant ID, and lastly we're gonna need a subscription ID. Okay, so whenever I get to the information where I get the information for my tenant ID and subscription ID, I'm gonna blur them out because these are my personal information. But for the client ID and client secret, I'm gonna keep it available because I'm gonna be deleting those after. So before we move any forward, I would just like to use the last Terraform command that we have, which is destroy, which basically should destroy all of the resource group that we currently have created before. And this should take a few seconds, actually up to a minute or two or so. And it viewed that all of the resources that we have created and is prompting us, do we want to continue? And we're gonna enter yes. And this should take up to a minute to do all of the work. And once that's done, we'll start working on Azure. And as we can see, the process has completed successfully and the 2 resources have been deleted from our Azure portal. Great. So right now what we're going to be doing is we're going to start setting up these 4 or getting these 4 information: client ID, client secret, tenant ID, and subscription ID. So now let's go back to our Azure portal. And now if we go here, we should see the one that we've created has been deleted because we have executed the Terraform destroy. Great. So the first thing we're going to be doing is we're going to go to the Active Directory. And then within the Active Directory, we're going to go to the app registration, as you can see here on the left. So app registrations. I have already created an app registration before, but we're going to create a new one. So we're going to click on the plus button, new registration, and basically we're going to give it this information. So I'm going to call it Terraform Service Principal CI/CD V2, because this is the second one that I have. And basically from the list here, we're going to choose the first one, which is accounts in the organization directory only, default only, and single tenant. So this is the one we're going to be using, and then we're going to click on register. And this should take a few seconds to complete. And now that we have our second service created, basically our app settings created. So what we're going to be doing here is basically we're going to take the client ID, and we're gonna paste it here, and then we're gonna take the client secret, we're gonna take the tenant ID, and then after that basically we're gonna be generating the secrets. So how are we gonna do that? On the left hand side we can see here we have secrets, certificates, and secrets. So let's click on that. And within the certificates and secret, let's click on the create a new secrets button. And here we need to give it a description. So the description, we can say it could be access to info, for example, and we'll give it a 6-month expiration, and we click on add. Great. So now we have the secret available for us. So let's copy this and paste it here. And just so you know that as soon as you create a secret, this value here will only exist for like I think 5 minutes where you're able to see it. After that it will be hidden, so you're not able to see it again. So it's a very good idea to copy it from now and put it on the document that we currently have. So once we have added those, now we need to go to the newly created Azure directory and give it access to the required resources. So let's go back to our home and let's click on the subscriptions and let's choose the subscriptions that we have. And here let's copy the subscription ID and we'll paste it here. Great. Now what we want to do as well, other than that, is we need to give access to that application to manage our subscription. So inside our subscription, let's click on access control. And from within the access control, we're gonna be granting access. So add the role assignment. From the contributor list here, we're gonna choose contributor. Sorry, from the list here, we're gonna be choosing contributor. And we're gonna click on next. And then basically we're gonna select a member. And here we're gonna see the application that we have created. So let me see what was the name of it. Okay, let's go back to Active Directory. Let's go back to app registration. And let's get this name. And we can see it's available for us here. Perfect. So let's choose that. And we click on select. And then let's click on next. And then after that, we put review and assign. And this should take a few seconds to complete. Perfect. Now it has been created successfully. So the next step for us is, now that we have these 4 available, so now we have our client ID, client secret, tenant ID, and the subscription ID. What we need to do is we need to add them to our system variables. So let's go to our web browser. Let's go to Google. So as you can tell, I don't like to enable anything on my machine, so we turn them off. And now from here, what we can do is we can actually set up. I have already done this on my machine, but I just want to show you how you can set up on your setup system variables. So if you're using Windows, I think there's a very good article here. Let me see if I can find it. Yes, so here, for example, this will allow you, I'll leave these links in the description down below for different types of OS, so you can see how you can set it up. So this is for Windows, and I'll find the one for Mac as well. And I think for Mac, let's change this variable, put OS X. I think this is it. Yeah, I'll add these 2 links to the description down below, or you can Google them yourself. It's very easy to set up the system variable. So once you do, once you have added those to your system variable, make sure you have and you have them in those exact same format. So The system variables needs to have, for example, arm underscore client ID, arm underscore client underscore secrets, arm underscore tenant underscore ID, and the last one is arm underscore subscription underscore ID. These needs to be in the exact same format, so Terraform will be able to recognize them. So once we have added these in the system variable, Terraform will be able to actually utilize them, and have already added mine into my system variable, so that's why it's working for me. Great. So once we have done that, now what we need to do is we need to jump into Azure DevOps. So now let's go back to our web browser and let's open Azure DevOps. So it's gonna be dev.azure.com, and you can sign in here, or you can create your free account if you don't have. Let's sign in. So here, this is the one that I created earlier. So I'm gonna create a new one, and we're gonna create a new project, and this new project, we're gonna be calling it say Terraform sample 2, for example. And basically from here is we're not gonna give any description, we're gonna make it public. And here we're gonna be utilizing Git. Perfect. And let's do create. This should take a few seconds. Perfect. So the next step for us after we create this is we need to actually enable connections between our Azure DevOps and GitHub, as well as Docker Hub, as well as Azure. So we have three things that we need to connect our Azure DevOps to. So the first thing that we need to do is we need to go to project settings, which is here on the lower left hand side. And once you click on project settings, you should see something called service connections. So if you go here under pipelines, you have to see something called service connections. And once you click on service connections, it will give you the option to create one. So we'll have to create 3 right now. So let's click on the create one. And from this list here, the first thing we're going to be utilizing is we need to connect it to Azure Resource Manager. So we choose Azure Resource Manager, we click on next. And basically we're going to be utilizing the service principal, which we have already created before. Next. And here it's going to tell us that if we want access to the subscription, we're going to say yes. And let's wait until the subscription is loaded. And basically here we can see the subscription, and then here it's going to ask me for the resource group that I want to give access to, and basically I'm going to give it to the resource group that we have just created. So, or let us not give it access right now. Let's go to the details and give it a connection name. And we're just gonna call it the Azure resource group without any description. And we're gonna grant it access to all of the pipelines. And we click on save. Okay, I think this is it. Let's click on back, and again, sometimes the pop-ups create these issues. If this still doesn't work, we need to format it. I find like sometimes Azure DevOps works really well, but sometimes you have these minor issues here and there. So let's click. So this is the one that we want, pay as you go. And we need to log in again. Okay, now that should be fine. Is there anything here? So this is the only resource group that we have. We don't really need it specified right now. Gonna call it Azure Service or Azure Resource Manager Service. And now let's click on save. Okay, this should take a few seconds. Perfect. So now we need to create another one. So let's go back to new service connection. And right now we need to choose a Docker registry. So we click on next. And basically we're going to be utilizing Docker Hub. And we need to specify our Docker ID. So my Docker ID is going to be Mohamad Lawand. And let me get the password. So we don't really need to put the email here. Again, Docker registry, next, Docker Hub, so it's gonna be Mohamad Lawand, and let's remove the email, and let's click on verify. I think this is my password, yeah, verify. Great. So now we're going to need to give it a connection. So let's give it Docker registry service. Great. So verify and save. Perfect. So once we have done that, we have gave it access to these two that were really important for us. The next step is we're going to start building our pipelines. So in order for us to do that, let's go back to our here, as we can see from the menu. Let's click on this one actually, and we can see here we have like a rocket icon, and next to it there's like a pipelines. Now let's click on pipelines, and we can see here we have a button says create pipeline. So what we're gonna be doing is we're gonna be choosing a YAML file. So it's gonna be choose GitHub, and then from here it's gonna request us to authenticate with GitHub. So let's authenticate it. We need to input Perfect. Now we'll just choose the repo that we want, and this is the latest repo that we have. And basically once we do that, it's gonna ask us to confirm. So here I'm just gonna select the repo again. I think it's already here. Yeah, I'm just gonna click on approve and install. Just take a few seconds. Yes. Continue. Perfect. So now that we have went to this, what we're gonna be doing here is we're gonna be choosing Docker. So here is starter pipeline, existing YAML files, none of that. Let's look for Docker here. So we have here Docker image. Validate and configure. And now as we can see, once we have done the validate and configure, we have a Azure pipeline which has already been created for us. Now that we have this ready for us, what we're going to be doing is, because we don't really just want to build up image pipeline, the Docker image, we want to build it and we want to push it. So before we do anything else, let us discuss the structure of this Azure pipeline. So we can see here we have the trigger, which basically whenever there's any changes in the Git repo, we're going to be actually focusing on the resource itself, which is basically the where the change is going to be happening. So this is the tag, which is the build ID number. This is really important because basically we're going to assign this tag to every Docker image that we're going to be building. But for now, let us just like put it on the side. So something that we want to discuss as well is the stages. So here, the Azure pipeline run in a proper hierarchy. So we need to execute the steps one by one. We cannot execute them in parallel. So we need to execute them one by one so we are able to actually get to the desired result. So as you can see here, the first one is build, which is building an image. And then this staging has different jobs, and every job has tasks. So basically we define the stage, for example, initialize, for example, Terraform. And then the second job is actually click or execute the Terraform init, then execute the Terraform plan, and then execute the Terraform apply. So these are 3 tasks within a single job. So after that, for example, we have, so basically we define the stage, then we define the job, and then based on that, we define the task. So here the stage is build, we're building the image, and then the jobs is basically, the first job is to actually build the environment, which is utilizing the Ubuntu latest. And then for that, we're actually building the Docker image, and we're taking the Docker file from the root directory. So this is like a quick overview on the Azure pipeline. Now let's add some more functionality into this. So let's click on Show Assistant here. And from the Show Assistant, we're going to be utilizing the Docker build and push Docker images. So it's going to be, where is the Docker ones? So this is so we're going to be choosing this one, Docker build or push Docker images. Let's click on this. So here we have the container registry. So we're going to choose Docker container registry and the container repository. So for basically, we're going to be adding the name of our application, which is on Docker Hub. So if we go back to Docker Hub, and we're going to choose this one. So Mohamad /sample API. Let's remove these spaces. We don't need them. And then basically, once we have done that, all we need to do is click on add. We don't want to change anything within these commands here. So let's click on add. And as you can see here, oh, okay. Because something you need to be very careful. You need to make sure the cursor is at the end, not inside any of the code here. Because if it is inside any of the code here, it's going to push it into that step. And YAML files are really, really sensitive to spacing and really sensitive to basically anything. So be very wary and very careful when you do any changes to them. So let's go back here. Let's put it on a new line and let's go back and redo this step again. So we'll go to Docker. Okay, Docker, build and push. So we're gonna choose the Docker container registry. I think it's Mohamad Lawan / sample API. Yes, sample API, let's add that. And we're gonna leave it the same and click on add. And as we can see here, this task has been automatically created for us, and we can see it's complaining because it's not on the right formatting. So let's put it under the right spacing. So as you saw, when it was all the way to the left, it was started to complain, but now it's happy because we put it under the right format. So once we have done that, we don't really need this anymore, because this building of the image was automatically gonna happen here. So let us delete this. We don't really need this. Or actually, before we do that, let's take this tags thing here, copy it, and let's put it here, because we're going to be utilizing those tags. But let us delete this. We don't really need this anymore, and let's delete this. Okay, great. So now what we did is we just changed from actually only building the image to actually pushing directly to Docker Hub once it has been built successfully, and it's taking the Docker file to build that image. So basically here we're just specifying that's gonna utilizing the Docker registry, and then basically here we're specifying which repository is gonna be able to push to that, and then we're giving it the command that you need to build the Docker image and then push it to Docker Hub, and then here we're telling it which Docker file it needs to look for in order for it to execute that, and then here we're just basically taking the tags that we have here, because this tags here we're gonna be able to attach it to the version of the repos that we have. Great. So now we have that. Let us go back to Docker Hub and let us delete this, and let's see if this pipeline will be able to create this for us based on our repo. So let's delete this repository. We have to input the name here, and let's delete it. Perfect. And now let's go to the new pipeline that we have created and click save and run. So here is gonna commit message. We'll keep it as is. I want to put it in the main branch, and let's click save and run. This should take also few seconds to be completed. Okay, perfect. So now it should start running, and let's click on that. And here we can see the actual process that it's taking in order for it to build this. So let's see what's gonna happen now. So we can see it's actually found the Docker image. It started building it. It's going through the process of building that image. It's putting it. This should take a few seconds, and we can see here the code that we have already inputted here. It's already running. Now we should see expose port 80. Yes, expose 80. And let's give it another minute or so for it to be completed. So now we can see it has completed successfully, and if we go back right now to Docker Hub and we refresh, we should see that the Docker image has been built successfully and it has been pushed, and we can see here it has pushed a few seconds ago. Perfect. So now we have the process or setting up from the pipeline. Now what we're going to be doing is we're going to go back to Visual Studio Code and actually pull these changes so we are able to edit those pipeline within Visual Studio Code. So let's navigate to Visual Studio Code and let's do git fetch. Let's put the password correctly. Great. And now what I'm gonna be doing is I'm gonna add the changes that I have. Git add, git commit. Let's say it's gonna be updating, adding terraforms. Actually, it's gonna be adding Terraform. Perfect. And now I'm gonna pull all of the changes. So git pull. Let's put the password. And just take a few seconds. So let's close this. And we can see here that the Azure pipeline is available for us locally to utilize. Perfect. Now let us do some manual changes and we'll take it from there. So the first thing that we're going to be doing is let us change here, for example, let us add more names. So we can add cars, for example, Mercedes. Let's add a BMW. Let's add a Jeep. I know this doesn't make any sense, but just for doing any testing data. Honda. Let's see. So we put Ferrari. Okay. So this is what we currently have. These are the small minor changes that we want. Now let us comment these changes and see how this is gonna work. And see if the entire process is actually gonna be working as it should. So git add, git commit, minor changes, and git push. And let's put the password. And it has been pushed successfully. Now if we go back to our portal, and we can see the pipeline has already started again. And if we click on it, we can see it's actually working. Let's give it a few seconds until this is finished. And we can actually check if it has been pushed successfully here, because we're gonna have a different tag number. So currently we're on tag 10. I think it's more than 10. Yeah, 11. So let's give it 14. So let's give it another few seconds until this is finished. It should be on 15 now. Okay, great. Now it has finished. Let's go back to Docker Hub. Let's refresh this. And if we put on see all, we can see that we have tag number 15, which was created a few seconds ago. Perfect. So now that we are on we know that our process work and we have the full life cycle except for the Terraform. So currently what we did is once we push our code to GitHub, the Azure DevOps pipeline is gonna pick that up. It's gonna take the Docker image. It's gonna build that image. It's gonna push it to Docker Hub. Perfect. Now what we are gonna be doing is we're gonna add Terraform and integrate Terraform into this pipeline. So how are we gonna be doing that? So first So the first thing we're gonna be doing is we're gonna go back to our Azure DevOps. And let's go back to pipelines. And as you can see here under pipelines, we have something called library. We're gonna click on that. And we're gonna add new variables under the library one. So click on new variable group. We need to give it a name. I'm just gonna call it for now Terraform sample library. Okay, great. Allow access to all pipeline. That's what we want. And now we want to add variables. So we want to add the 4 variables that we have created for Terraforms from before. So these 4 variables, they're gonna be these 4 that we have already, So client ID, client secret, tenant ID, and the last one is the ARM subscription ID. And once we have those ready, let's click on save. And let's log them up so we cannot really see them. And let's click on save again, and we can see it has saved correctly. Perfect. Now that we have these information there, okay. So next step for us is we need to discuss something called the state. So let's go back to the Visual Studio Code and let us do any changes to our main.tf file. So here, for example, if I want to change the name of this, let's call this v1, for example. Before we do that, I want to check the status. So let's see, Terraform init, it's working. Terraform plan. So let us look at what's happening here. So once we have created on Terraform plan, Terraform has created for us a plan of what's gonna be doing once it actually wanna execute the changes into Azure. And we have discussed this point before, but something that we wanna discuss here is this file here. So as you can see, this file here has been created for us. It's called terraform.state. And basically the terraform.state file is what keeps track of the changes that's going on. So for example, if we are doing if we want to update the infrastructure, we want to change the infrastructure, we want to do anything related to the infrastructure, the terraform.state files needs to keep track of all of these changes. So if we want to revert back, we want to do anything, it's going to be referring back to the terraform state file in order for it to execute all of this. But if we're going to be executing this on GitHub, the pipeline will not be able to create this on every Git repository. So for example, let's say we push the changes, the pipeline will not be able to create a temporary file on our repo called terraform.tf state and then execute it from there, because it's not sustainable that way and it's not gonna work. So in order for us to fix this, basically what we need to do is we need to have a storage account on Azure, which is gonna be a blob storage account. And that blob storage account, its main responsibility is going to be only handling the terraform.tf state file. And basically, any changes that we're going to be doing to our Terraform files, the TF state is not going to be saved locally, it's going to be saved on the cloud. And that way that the pipeline will be able to utilize it, and we're going to be able to utilize it, and that way the state is going to be consistent across every request or every change that we're going to be doing. So how are we going to do that? It's very simple. We need to go back to Azure portal, and basically let's click on resource group, and let's create a new resource group. Let's refresh. Okay, let's create a new resource group. It's gonna be under my subscription, and I'm gonna call this resource group storage state Terraform state. Okay, I'm gonna put it in South UK South. Great. And review and create. So this should take a few seconds. It has been already created. Let's go to resource group. Perfect. Now that we have this here, now we need to create a storage account. So let's go back to here and just create a resource. And let's search for storage account. And then we're gonna click on create. So now that we have this, what we need to do is we need to create our storage account name. Let's call it, for example, Terraform storage for state. Any random name, because this is only a sample. But if we're actually deploying it properly, we need to give the proper name. So we're gonna give it a standard. We're just gonna go with LRS. And let's put create and review. And now let's create on create. This should take also a few seconds. Okay, once this has been created successfully, let's go to this resource. And now we need to create a new container, because basically Blob Services has containers. I'm not sure if you're aware of it. I have another video which explains all of those services, which I'm gonna link here on the upper right hand side. But for now, let's click on the plus and we'll choose a container. And for this, we're gonna give it a name, and this name we're gonna call it Terraform data. And basically we're gonna keep it as is. We're not gonna change anything here. I'm just gonna click on create. Perfect. So now we have done that. Let's go back to our Visual Studio Code, and inside the main.tf file we need to do some changes here in order for us to be able to utilize that Terraform file inside the storage container that we have created. So the first thing that we're gonna be doing is we need to add the backend service of Terraform. So we're gonna be adding it here. After the initialization of the provider, we're gonna be adding that. So we have to type Terraform, and then we need to specify backend, which means that it's gonna be for the configuration of that resource that we're gonna be utilizing, and it's gonna be for Azure RM. And then from that point forward, basically we're gonna specify the resource group that we want. So resource underscore group underscore name. Let me find the name of that resource group. So if we go back here, I think we are able to see that resource group name is this one. Perfect. And then we need to specify the storage account. And the storage account is this one. And then after this, we need to specify the container name. And the container is the one we just created, which is TF data. And the last one is the key. So basically it's going to refer to the file name that we want to actually store inside the container. And this is going to be the Terraform file that we have, which is going to be terraform.tfstate, which is going to be this one here, because basically this is the file that we want to actually store inside the blob storage. So let us do a quick summary of what this does. So here we're just specifying that we want to, the word Terraform here specified that we want to do some configuration, and then here the word backend, it means that we want to change how stuff is being handled when it comes to handling changes within the Azure cloud. And then basically here we're specifying some of the changes that we want to implement. So this means that this is where we're gonna store some of the temporary files. So we specified here the resource group that we're going to be utilizing, the storage account name, the container name, as well as the key, which is actually the file that we want to save. And after that, let us not push this into our GitHub. So let us add them to the git ignore. So let's choose this and this. And I think we can add them to git ignore from here. No, we can't. So let's add them manually. So here, for example, we'll put terraform.tfstate, and we'll put terraform.tfstate.backup. Save. So now these files, when we don't want them to be committed anymore. So once we have done that, let us post these changes. So git add git commit -m updating Terraform, and it's going to be git push. Actually, what we can do as well, let's delete those files. So rm, yeah, and rm, yes. And now let's git add git commit -m removing tf state file and git push. Okay, great. So now that we have done that, let us try doing the git init again and see what's happened. So git init, sorry, not git init, Terraform init. So now we can see it's actually initializing it. Now let's do the planning. So Terraform plan. Perfect. And as we can see, this has completed successfully, but we don't see anymore that the Terraform state is here. Let us go to our storage account in the TF data and see if it's actually there, and we can see that it has been automatically created from the Terraform state. We cannot see it here, we have to download it, but basically we see that it has been created a few minutes ago, actually a few seconds ago, and it has been uploaded and utilizing the storage account instead of using it locally. Perfect. So once we have done that, Now what we need to do is we need to add the provisioning state, which is actually creating the entire infrastructure from within the Azure pipeline. And this is what we're going to be doing next. Now let us integrate the Terraform service inside our Azure pipeline. So let's open our Azure pipeline and let's start adding the below tasks. So before we said that everything within Azure pipeline is going to be built on stages. So the first stage that we have is actually building the image. The second stage that we're going to actually utilize is building and provisioning the infrastructure. So we're going to specify the stage, and please be very careful that this is going to be very case sensitive, because YAML is very case sensitive. So provision is going to call the stage, and then we're going to give it the display name, and we're going to call it creating Terraform on Azure. And then we're gonna say what does it depends on, and besides we're gonna depends on the build stage. So basically that stage needs to be successful before the stage starts. So it depends on we're gonna say build. I think build with a capital B, yeah. And then once that is done, we need to specify the jobs that we're gonna be doing. So jobs, and the first jobs that we're gonna have is basically the provision. So job and provision, and we're gonna give it its name, which is gonna be basically provision the container instance. So display name is gonna be provision container instance. And once we have done that, the next one is we're gonna be specifying the pool, which is gonna say it's gonna be a Ubuntu. So pool, and then here is gonna be specify the virtual machine image, and we're gonna say it's gonna be Ubuntu. I'm gonna take the latest version of Ubuntu. Great. So once we have done that, now we need to specify the variables, and basically the variables here is gonna be the vars that we're gonna be utilizing in order for us to deploy the latest tags. So for example, once we wanna build a new infrastructure, and we're gonna get a tag, and that tag basically we're going to be utilizing in order to update the Terraform files. So and actually that tag is going to be basically utilized in order to have a Docker container tag. So every Docker image that we build, that tag is going to be attached to it, so we can have unique tags, and we can actually facilitate to ourselves to have different tags there. So once we have done this, after the VM image, we're gonna actually start defining the variables, and from that we're gonna specifying the variable group, and we're gonna call it sample API variables. We're gonna create this after we finish initializing this. Now once we have done that, now we need to specify the steps. And basically the steps, it's gonna be scripts based. So we're gonna add the script that we're gonna be utilizing, and we put this so we can actually write on different lines instead of writing all a single line. And we're gonna be basically set -e, and then we're gonna specify the Terraform commands, Terraform init -input false. So it doesn't really require any input from us. So basically, before, if you remember, when we done it on our command prompt or terminal, it requests us, do you confirm this? We say yes. So this will not request that confirmation. And this is for the initialization. And now for the apply. So Terraform apply as well. We're gonna put input false, and we're gonna give it auto approve, so it automatically approve all of the requests that's gonna happen. Perfect. So once we have done that, now we just need to specify the name for this, and we're gonna basically name it run Terraform. It's a very simple name. So here, let us just fix those. Yep. So that's the name, and after we specify the name, we need to specify the display name. And it's gonna be run Terraform. Perfect. Once we have done that, now we need to specify the environmental variable that we have added inside our Azure DevOps. So we put environment, and then we need to specify the variables that we have. So if you remember, the variables were arm underscore client underscore ID, and basically the code, in order for us to be able to read them directly from the dev portal, is like this. So we need to put the $size bracket and then the same name that we have gave it there. So it's going to be arm client ID, and then we'll give the other one, which is arm underscore client underscore secret, and it's going to be $sign arm underscore client underscore secret, and the one after that's going to be arm underscore tenant underscore ID, and then arm underscore tenant underscore ID as well, and the last one is going to be arm underscore subscription, if I can type, and we can put ID and colon $sign arm underscore subscription underscore ID. Great. And lastly, excuse me, and lastly, we need to specify the Terraform file. So tf var underscore image build, and this image build, we're gonna take the tag that we already specified before. Now we just need to fix the formatting. So let's see for the name. Oh, we shouldn't put space inside the name. Okay, so that's why we need to be very careful when it comes with handling YAML files, because the formatting is gonna be a nightmare. So luckily right now everything worked here. So one thing that we need to do is we need to make sure that we're deploying the latest version of our Docker image to Azure. And to do that, we need to pass the image build number from our Azure pipeline to our Terraform. To do that, we need to do the following. So inside our main.tf, what we need to do is we need to add a new variable. And this variable we're gonna call it image build. And it's gonna be of type string. And we're gonna say the description for it is gonna be the latest image, the latest build version, sorry. Okay, so let us check one thing. So we can see here we gave the variable image build. So if we go back to our YAML file, we can see here that we have the tf var. So basically we are pulling the Terraform variables, and we're actually getting the same variable name, which is build image. And we can see here it's actually getting it build image is equal the same ones there. Great. Now what we need to do, and lastly, we need to update our Terraform file so it will take advantage of this. So if we come here into our Terraform file and where we're actually deploying the image, all we need to do is we need to update this so we can specify actually what is the version number. So we can put a $sign, and we can put brackets, and then we can put var dot build image build, and that way we can actually take the latest image build and we can actually deploy it. So this will make the image building dynamic for every deployment that we do. Great. So once we have done that, let us save. Let's open again the terminal, and let's add this. So git add git commit -m, and we'll give this the message of integrating Terraform with Azure pipeline. Great. Now let's click on git push. Let's type git push and add great. Let's put the password, and now we're pushing it. And now let's go back to our web browser and go to the pipelines, and we can see this is an old one which had failed. Oh, this one has already failed. Let's see why it has failed. The pipeline is not valid. Authorize resource. So let's click on authorize resource, and it says that we have automatically authorized it. So now let's check again, and what we can do is let's add any minor change and try to see it one more time. So let's go here and let's add another one which is called, for example, Renault. Okay, save and git add, git push, git commit. I call it sample data, and let's push this, git push, put the password now, and now let's go back to our web browser and let's refresh. So go back, check this. The pipeline is not valid. Job provision and value sample API variable could not be found. So let's check this sample API variable. Okay, so what did we call it inside? Okay, I know the issue. So because here under the library we called it tf sample lib. So let's take this, copy this, and let's update it here. Yeah, I think that's the issue. Let's save it. We need to make sure that the variable groups match with the one that we have created. So let us push this, git add, git commit -m, and we can actually say this gonna be update the variable group, git push, put the password, and now let's check here. Let's go back to the pipelines, and we can see that it has started to work, and we can see that they are starting to provision the container. This should take a few seconds, a few minutes to complete, so let's wait for it. And if we go here to the description, we can see that the stages that we have, since we have two stages, and we have the first one which is building an image, and then we have the creating Terraform, and because both of them rely on each other, we can see here that the Terraform stage has not started until the build image has been completed successfully. And now we can see that the first one has completed successfully. Now we are actually creating the Terraforms. And we can see here in the steps actually started to work. So it checked out the one that I have. It's running the Terraform. It has successfully initialized. We can see that everything is being created as we speak. Just to take roughly a few minutes to complete. Perfect. Now that the image has run successfully, now let's go back to our Azure portal. And let's go to the resource group. And now we have seen the resource group has been recreated for us again. And now we can see that sample API has been recreated for us again. And now if we take this and try to run it, let's put persons. And we can see that started to work again. I think this one, the old one. Let's refresh this. And we can see that all of the changes has been automatically uploaded here. Great. So this is basically summarized and the full step. So what we did is, first of all, we have discussed what is infrastructure as code. Then we have discussed what is Terraform, and then we started building our pipeline. So we created first a sample API. We created the Docker image for it. And then basically we have configured Terraform locally. We were able to provision the infrastructure locally on our machine. Then we have started to automate the entire process. So then we have created the Terraform locally. We have then created the Azure pipeline. We connected it with our repository. We have updated it from there. And then after we done all of that, then we have linked the Terraform into our Azure pipeline. And then now we have a full cycle. So every time we update any code, this entire cycle is going to happen again. And basically we are able to update the Docker image, update the Azure container registry and actually update the application online on Azure without us doing anything, utilizing the automated pipeline. Thank you very much for watching. Please like, share, and subscribe if you like this video. Please ask all of your questions in the comment if you have any, and have a great day.